Welcome everyone. In this video I'm going to talk about photoelectric effect experiment setup. So remember in this one, in previous video kita ada metal kat sini dengan work function W naught and the energy given by this photon E equals to hf naught, and the electron will get emitted from the surface of the metal with energy K max, kinetic energy maximum. So in order for what can we do and how are we going to set up? How are we going to direct the electrons to? So it is basically, we know that electrons is easily attracted to positive plate. So we provide it with a positive plate. How are we going to make a positive plate? Is by adding a battery or direct current power supply, where we are going to connect with emitter, and this is how the circuit is connected. We can see that terminal positive connect to an anode, and the metal that we shine the lights on is the cathode. So the DC power supply act as a pump to give direction to the photoelectron to move to anode, or in this case we call this anode as a collector. And then the function of emitter is to measure the current passing through the circuit. So bila kita tengok ada deflection pada jarum emitter, ini bermaksud elektron ini sudah sampai ke anode, dan circuit itu akan bergerak, dan kita tahu bila elektron bergerak, dia akan menghasilkan current. Seterusnya, kita tahu bahawa K max equals to half mv max squared. Ini ialah rumus untuk kinetic energy. So bila frekuensi tinggi, K max juga akan ikut tinggi, dan high intensity light or brightness, high brightness of a particular light does not affect K max. Means that if you have the brightest light, you still cannot get the higher K max. It is all based on the frequency. And then, in order for us to make sure that the kinetic energy is totally passed along the circuit, we have to make sure we have to put these two terminals in vacuum chamber. This is so photoelectrons won't collide with air particles, because we know collision will cause photoelectrons to lose its kinetic energy. Now sometimes a setup is made of curved metal like this. This is to give more surface area for the photon here to strike on it. So as the surface area increases, the number of photoelectrons also increases. So this will give out more current to the circuit, and we can see bigger value of current. So bila kita dah set up kita punya apparatus, of course kita akan boleh mula dapat bacaan, dan daripada situ kita akan mula menganalisis graph. So we have 3 graphs. Number 1 is K max versus frequency. Number 2, current versus voltage. Number 3, stopping potential Vs versus frequency. Now this number 3, I'm going to talk about it on the next video perhaps. So we go for the first graph, which is K max versus frequency. So at the Y axis is the K max in electron volt unit, and then we have the frequency in hertz as the unit. Now we take a look at, first we have 2 types of metal. This one is metal A, and this one is metal B. So the blue line is metal A and the purple line is metal B. Now at here you can see that this is at the x-intercept. At the x-intercept, where we can find that the K max is equals to 0. We can see that in previous video that I talked about, when the K max is equivalent to the threshold frequency of the metal, or you can say that the work function of the metal, Kmax equals to 0, means that there is no extra energy for the electron to move out of the surface kan. Dia cuma boleh keluar ke permukaan saja, dia tak sampai boleh melompat keluar ke udara. So Kmax equals to 0. So di sini ialah kita punya threshold frequency of metal A, F0 A, dan di sini ialah F0 B, which is the threshold frequency of metal B. And then we can see from this graph, there's a gradient, and this gradient, which is the same for metal A as for metal B, we can see that the gradient M is equivalent to Planck's constant H. Alright, that's all. For the current versus voltage, di mana current dalam unit ampere melawan voltage dalam unit volt, kita lihat di sini bahawa intensity, kalau kita satu kali ganda intensity of light, kita akan dapat I max di sini, bahagian sini, bacaan dekat pintasan Y di atas. Kemudian kalau kita terangkan lagi cahaya tu, lampu yang ada foton tu, kita akan dapat intensity 2 kali ganda, maka current yang lalu juga 2 kali ganda. Dan kalau kita terangkan lagi lampu tu, kita akan dapati current dia akan bertambah. Tetapi perhatikan, kita punya point sini tetap sama. Apa itu? Kejap lagi saya akan tunjuk, iaitu VS, iaitu stopping potential. Okay, kita tengok dulu macam mana intensity itu mempengaruhi ke arus yang lalu, jumlah arus, value arus yang lalu. Nah, bila intensity bertambah, number of photon yang menghentam permukaan metal itu akan bertambah, betul? Kalau asalnya ada 10 foton, 10 biji foton, kali ini akan bertambah 20 biji foton ataupun bertambah lagi 30 biji foton. So bila bilangan foton ini bertambah, apa yang akan jadi? Number of photoelectron ejected with the same Kmax also increases, juga akan bertambah. So kita akan dapati jumlah electrons daripada 10 biji akan pergi ke anode, jadi 20 biji, jadi 30 biji. Tetapi kena ingat Kmax dia masih sama. Hanya yang bertambah ialah bilangan photoelectron. Kemudian bila bilangan photoelectron itu bertambah, bukankah current juga akan bertambah? Ya, so maka kita akan dapati bahawa Imax akan juga meningkat bergantung kepada intensity. Okey, kalau kita tengok ketiga-tiga intensity yang berbeza, kita masih juga dapat VS yang sama, iaitu stopping potential yang sama. Ini kerana ini menunjukkan bahawa Kmax-nya, walaupun bilangan foton ini bertambah, Kmax-nya masih sama. Kerana Kmax berdasarkan equation EVS equals to Kmax. Now, stopping potential saya akan explain lagi dalam video yang seterusnya. So, basically, itulah dia kita punya graph current versus voltage. Dan yang pertama, kita punya graph ialah Kmax versus frequency. Okay? Terima kasih.